Question 4a. Construct the triangle ABC where the length of AB is 8 centimeters, the length of AC is 5 centimeters, and the length of BC is 7 centimeters. Let's start by drawing in the side AB. We know that this side should be 8 centimeters long. For this, we simply get out our ruler and draw a line 8 centimeters long, labeling the endpoints A and B. We need the length of AC to be 5 centimeters. The next step is to set our compass to 5 centimeters, put the point at A, and to draw out a little arc. We need the length of BC to be 7 centimeters. So our third step is to set our compass to 7 centimeters, put the point at B, and draw an arc. The point where these two arcs meet is C. Using our ruler, we join this point to A and we join it to B. And this completes our triangle. Part B. The diagram shows a square of side length 2k centimeters. Write down, in terms of k, an expression for the area of the square. Finding the area of a square is quite simple. All we have to do is take the side length and square it. In our square, the side length is equal to 2k. So our area will be 2k all squared. Inside our brackets, we have a 2 and a k, and all of this is being raised to a power of 2. When you have multiple things being raised to a power, each one gets a copy of the power. So here, the 2 gets a copy of the square, and the k gets a copy of the square. So 2k all squared is equal to 2 squared times k squared. And here we can simplify. 2 squared is equal to 4. This gives us our final answer. The area of the square is equal to 4k squared. An isosceles triangle with side lengths of 20 centimeters and hypotenuse of length 2k centimeters is removed from the square, as shown. Find the value of k, correct to 2 decimal places, and the area of the remaining shaded section. To begin, let's focus in on this white triangle. We've 2 side lengths of 20 and a side length of 2k. An important observation here is that the white triangle is a right-angled triangle. This is because the 4 corners in a square are all right angles. Well, we've a right-angled triangle and we're concerned with the 3 sides. In this situation, we can use Pythagoras' theorem. This can be found on page 16 of the formula book. It states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. In the statement of the theorem, the hypotenuse is labelled as C and the other two sides are labelled as A and B. Well, the hypotenuse is the side which is opposite the right angle. In our triangle, the side opposite the right angle has length 2k, so we'll let C be equal to 2k. The other two sides can be labelled as A and B, and it doesn't matter what order we do them in. Here, A will be 20 and B will be 20. Now that we know A, B and C, let's sub in to Pythagoras' theorem. Our goal here is to find the value of k. To start, let's do some simplification. We can get out our calculator and type in 20 squared plus 20 squared and we'll get 800. 2k all squared is equal to 2 squared times k squared, which is equal to 4k squared. This is similar to the calculation we did in the previous part of the question. Remember, our goal here is to solve for k. In other words, to isolate k all by itself on one side of the equation. To do this, I'll need to remove the 4 in front of the k and the 2 in the power of the k. Let's start by removing the 4. This 4 is being multiplied by the k squared. The inverse of multiplication is division, so to remove multiplication by 4, I'll divide both sides by 4. Now, I'll need to remove the square. The inverse of a square is a square root. So to remove a square, I should square root both sides of the equation. So our answer for this part of the question is that k is equal to 14.14 centimetres. As well as finding k, we are asked to find the area of the remaining shaded section. Well, looking at our picture, the shaded section is what we get when we start with the square and remove the white triangle. So the area of the shaded section will be the area of the full square minus the area of the white triangle. So the strategy here will be to find the area of the square and find the area of the white triangle and then subtract them away. In the previous part of the question, we found an expression for the area of the square. The area of the square was equal to 4k squared. Well, we've now found k, it's 14.14, so if we sub this in, we can find the area of our square. When it comes to the area of the white triangle, there's a formula on page 9 of the formula book which will help us. It says that a triangle with a base of A and a perpendicular height of H has area capital A equal to a half times A times H. The white triangle has a base of 20, so A is equal to 20. It has a perpendicular height of 20, so H is equal to 20. We can find our area by subbing these values into the formula. Now that we know the area of the square and the area of the white triangle, we can find the area of the shaded region by subtracting these two numbers away. Our final answer here is that the area of the shaded region is 599.7584 centimeters squared.